So we were talking about matrices. Matrices is nothing but a rectangular representation of elements, right, in a neat rectangular form. And the numbers or the entries that there in the matrices can either be real numbers or complex numbers. Okay. And we were trying to find the operations on matrices. And in yesterday's class, we studied what are addition of two matrices and what is difference of two matrices, namely A plus B or A minus B. And also we found out if a matrix A is given, how to find K into A. K means one scalar. Scalar means like numbers 2, 3, 4, not a vector. Okay, so we found out 3A, 2B like that, isn't it? So these are the three operations that we did in yesterday's class. We'll continue with it now. And I want to define more number of matrices, or rather the type of matrices. So what are the types of matrices that you know or you have come across? Can you tell me what are the types of matrices?
Diagonal, square,
Diagonal, very
cube,
good. Cube, okay.
diagonal, square, cube, triangular
Cube,
matrices.
parallel. What is it?
அப்புறம் ஸ்கேலார் மேட்ரிக்ஸ் மேம்.
இருப்பா சத்தமா சொல்லு.
அப்புறம் ஸ்கேலார் மேம், ஸ்கேலார் மேட்ரிக்ஸஸ், ஸ்கொயர்
Scalar,
கியூப்,
okay.
diagonal,
ம்.
யூனிட் மேட்ரிக்ஸஸ்,
அப்புறம்
யூனிட் மேட்ரிக்ஸஸ்.
யூனிட்டா கிஷோரா
அப்புறம்
பேசுறது?
யா மேம், நான் தான் மேம்.
ஓகே சொல்லுப்பா.
யூனிட்,
யூனிட் மேட்ரிக்ஸ்.
diagonal, அப்புறம் வந்து that's all my மேம்.
That's all. Okay, very good கிஷோர். இது என்னது இது ஸ்கொயர் மேட்ரிக்ஸ் கியூப் மேட்ரிக்ஸ்னா என்ன எனக்கு தெரியலையே.
இப்போ வந்து ஆட் வந்து 2 into 3 இருக்கு மேம். அது ஆட் வந்து 2 to 2 இருக்கு மேம். அது கியூபிக் வந்து ஆட் வந்து 3 into 3 இருக்கு மேம். அது ஆர்டர் வந்து
புதுசா சொல்லியே ஏதோ புதுசா ஒரு கணக்கு சொல்லிட்டியே எனக்கு.
யூனிட் மேட்ரிக்ஸ்னா என்னது மேம் அப்பனா?
நான் சொல்றேன் ஒன்னு நான் சொல்றேன் சரியா? We'll start one by one. So these are some of the matrices. Cube நான் கேள்விப்பட்டதே இல்ல கிஷோர்.
I don't know ma'am.
Okay, that doesn't exist. Sure, no problem. Very good try. Very good. So we don't have cube, we just have rectangular or square. Adha. Okay. So rectangular matrix is what we studied in yesterday's class. So it's 4 by 3 or 3 by 4, sorry, 3 by 4, this one. 3 rows and 4 columns. So 3 by 4. So dimensions m and n are not the same, so they are referred to as rectangular. Okay. And square means it's again an arrangement of elements like this, whereas you will have same number of rows, same number of columns. So what do you have here? 3 by 3. This is called a square matrix. So m by n, whenever m is equal to n, I call that matrix as a square matrix because the sides are the same. That's what. Okay. Understood, children? Did everyone understand what is a rectangular matrix and a square matrix?
Yes, ma'am.
Okay. Scalar matrix. Scalar matrix means you will have only scalars like 2, 3, 1, 1, 5, 8, like that. Mostly whatever numbers you're writing. Because I told you in the beginning, it can either have a real number or a complex number. Generally, we have only K into A. So K is scalar. So if everything is we call it, okay. It's about scalar. This if I take a 3 by 3, something like this. And what I have drawn, this is the. So what are the diagonal elements here? The diagonal elements are A, C, D. Correct? I refer diagonal மேல இருக்கிறது பாதியா பிரிங்க அப்படியே ஸ்கொயர் மேட்ரிக்ஸ்ல தான் அப்படி பிரிக்க முடியும். ரெக்டாங்கிள் மேட்ரிக்ஸ்ல பிரிக்க முடியாது. Please make sure of that. Okay? When you want to write a diagonal matrix, first of all, the first condition should be, it should be a square matrix. Only then you can equally divide into half, upper half and lower half. Okay? The first condition, it should be a, first condition, it should be a square matrix. Second one, you will divide the matrix from left to right, this way. not this way. Okay? We'll write from left to right. That's how we take the diagonal. This is the diagonal. These are the diagonal elements. That's the second condition. Understood, children? If you don't follow anything, you please tell me, okay? And then diagonal means what? Only along the diagonal you will have elements. All others would be what? Yes? Have you studied diagonal matrix?
Yeah, ma'am.
Yeah. So first one, it should be a square matrix. Second condition, you should take the diagonal from left to right. And the diagonal elements should be what? And what are the other elements? Any idea? Any guesses? Why do we give a special name called diagonal? Why a special name diagonal? Yes? Only along the diagonal you will have elements. Okay, maybe you can take like this. Only along the diagonal you will have elements. All others will be zero. That's why it's called diagonal matrix. Understood? Did everyone understand diagonal matrix?
Yes, ma'am.
Okay. Now in this diagonal matrix, this special example that I've given you is a scalar matrix. Why a scalar matrix? It is square. It's a square matrix. Only along the diagonal you have elements. And you see, all of them are same. So this is called a scalar matrix. Is that okay? So that's the next definition. So what are all the definitions that we have done? Rectangular matrix, the size would differ, m by n. M and n are not the same. Square matrix, m by n, whereas m is equal to n. So this is an example for square matrix. Okay. And then for scalar diagonal matrix, it should be a square matrix in which you take the diagonal from left to right, and the elements will be there only along the diagonal. All other entries are zero. Then that is called a diagonal matrix. And in the diagonal matrix, specifically, if the diagonal is going to have the same number. Understood, children? Up to here?
Yeah, ma'am.
Yes or no? Any doubts? Okay. And then last one, unit matrix. What do you mean by unit matrix? We've still got a few more. We'll just finish this list first. What do you mean by unit matrix? Everything is based on diagonal, okay? From diagonal, you have specific cases like scalar, unit matrix, and so on. So you would have guessed now. Only along the diagonal you should have elements. This is diagonal matrix. Then only along the elements you should have elements. But all of them should be same. Then you call it as scalar. Okay? A diagonal matrix in which along the diagonal you just have 1, 1 and everything else is 0. 1 stands for unity. Unit. So this is called unit matrix. Now are these three types clear to everybody? From diagonal matrix, we have specific cases. Like if the elements are all same along the diagonal, you call it scalar. If the elements along the diagonal are 1 and all others are 0, I call it as unit matrix. Clear, children?
Yes, ma'am.
Yes or no?
Yes, ma'am. Clear, ma'am.
No, you all didn't understand?
Clear, ma'am. Clear, ma'am. Understood, ma'am.
Understood? Okay, what about the others? Arunika?
Yes, ma'am. Understand, ma'am.
Patrick Rias? Okay. Varshini?
Ma'am, understood, ma'am.
Okay, ma. Nirmal, you said that you were not able to join. The problem is only if I join, you would be able to join. Okay. somehow the college had made that setting that only if the teacher joins, I think recent settings that they've changed in the college domain. So only if I join, you'd be able to join. So don't panic. I'll join 5 minutes before. Okay, generally. All right. Okay, let's move on. What's the next one? Okay, now we have finished this list. Any other type of matrices that you have heard of, children?
You have a
Ma'am.
null matrix, ma'am.
Sorry?
Null matrix.
Null matrix. What do you mean by null matrix?
Means it elements have a full of 0.
Very good. Null matrix. So all the elements are 0. So like this. Okay? Null matrix. Then
Identity matrix, ma'am.
all these identity matrix. What do you mean by identity matrix, ma'am?
Ma'am, all the elements should be same, ma'am. I1 means 1 0 like that, ma'am. I2
so?
means 1 0 0 0 1 0 like that. It will come.
Identity matrix. Is that identity matrix? Is it correct? Usually we call IS identity matrix, isn't it?
Yes, ma'am.
Same? Yeah,
Same number of rows and columns, ma'am.
Okay, same number of rows and columns you would have. So it's a square matrix, correct?
Yes, ma'am.
Okay, and then what is the special condition here? Why do you say it's identity matrix?
Only along the diagonals we have.
Okay, only along you're getting closer and closer to the answer. Only along the diagonals you will have. What will you have along the diagonals?
1, ma'am.
Very good. Where did you see suddenly the definition?
No, ma'am. I was just recollecting, ma'am.
Okay, very good. Very good. Okay, so come again. So what would you have? You would have a square matrix, and then only along the diagonal you will have elements, and that too you should have only one. All other elements are 0. So what's so special about this unit matrix, and what is the difference between unit matrix and identity matrix? Any difference? Very good, Eden, Shiny. I want others also to respond. Is there any difference between unit matrix and identity matrix? Okay, that's a homework. You should find out. Okay, I'll give you small work like this. You should find out what is the difference between unit matrix and identity matrix. Are they one and the same? Okay. Fine, children. Say yes or no. Will you find out?
Okay. Yes, ma'am. Okay, ma'am.
Okay. Any other matrix you know?
Ma'am, triangular matrix, ma'am.
All of
triangular matrix.
Sorry, triangular matrix. Okay, triangular matrix. Very good.
Ma'am, singular matrix.
Singular matrix. What do you mean by singular? See, if you tell me the names, you should immediately be able to tell also about the matrix.
A singular matrix whose inverse equals to its conjugate. That's
okay.
A inverse is equals to A star, like that.
A star. A star. It's called conjugate or what? What is the word that we use for star?
Conjugate, ma'am.
Let's come to this later. I will do this in the next topic because we'll be studying about A inverse and have you heard the word adjoint?
Yes, ma'am.
Okay, right. Transpose of the matrix and taking the adjoint. Okay, so we'll do that in the next class. Let's not talk about the singular matrix now at the moment. We'll just talk about simple matrices, types of matrices. So triangular matrix, I agree. Then, have you heard about column matrix? And what's the next one?
Yeah. Row matrix, ma'am.
What can I say?
Row matrix.
Row, very good.
Row matrix.
Row matrix, very good. Right, I want all of you to interact, okay? And I just find only 4 or 5 of them very actively involved, whereas the others are sleeping. Wake up from your slumber and then answer. Column matrix. What do you mean by column matrix, children?
Ma'am, it consists
What do you
of
mean
only
by-
column, ma'am.
Very good. Only one column it will have. Is this a column? So I will have like this, huh? Column is vertical. So this is an example for a column matrix. Okay. What about row matrix? Sorry. This is a row matrix, only one row. So this is a row matrix. All right, children. So that's a row matrix and column matrix. Somebody said it's a triangle matrix. So triangular, again, you should have a square matrix. Okay, only if you have a square matrix, when you can think of a triangle. This is my triangle matrix. Triangle matrix means you'll have a like this. So you see there's a triangle. Only in that triangle you'll have numbers. The remaining values would be 0. That is what you call as triangular matrix. And in triangular matrix itself, we'll have two types. Can you guess what they are? You must have studied.
Low up, ma'am.
Very good. Lower triangular. Very good, very good. Lower triangular matrix and upper triangular matrix. Okay? Lower triangle means this is one example that I've given, lower. So the beneath part, the part below the diagonal, if it has numbers and the other entries are 0, I call it as lower triangle. So how do we define an upper triangle? Upper triangle, if I take a matrix like this, I divide the diagonal like this. The upper triangle will have elements. And beneath you would have zeros. Am I right? Clear, children? So a square matrix in which the elements above the diagonal matrix, okay, I'm telling you the definition now. In a square matrix, if the elements above the diagonal matrix are non-zero and all other elements are 0, that matrix is called as upper triangle matrix. In the same way, in a square matrix, if the elements below the diagonal are numbers or elements, non-zero elements, and all other elements are 0, I call it as lower triangular matrix. Am I clear?
Yeah, ma'am.
Yes, ma'am.
Okay. We'll quickly do product of two matrices. That is important because we'll be using that for all the other theorems and verifications and all that. You must have studied multiplication of matrices or product of matrices. If you have a paper and a pen with you, you may take down these two matrices. I want to find product of A and B. Okay, if I give you the matrix, I'll do one matrix. Then I'll give you one example. You'll have to do it and tell me. Okay, let's take one example. Before I go into the example, I want to define what is a product of matrices. So if I have two matrices, the product of those two matrices is possible only if suppose I take M cross P and this is P cross N. Then if orders, the orders are something like this, M cross P, P cross N. This one and this one should be the same. So the product of the matrix will have order M by N. This one and this one. Okay, M by N. That is the product AB will have order this one. Whereas what is the order of the matrix A? It is M by P. For matrix B, it is P by N. And only for such cases, product is possible. Now that is one of the basic questions that even MSc students go wrong. In one of the interviews that we conducted, and we asked the student to multiply 2 by 3 and 4 by 3 matrix, she did it. after having studied UG and PG, very pathetic. It is not possible. These two matrices. Why? Because the number of columns here and the number of rows in the second matrix should be one and the same. Only then you can multiply. In this case, it's not possible. Do I make sense, children?
Yeah, ma'am.
Yes, ma'am.
Okay. Did everybody? Okay. So the number of columns of A should be equal to number of rows in B matrix. Only then A cross B or A dot B or the product, whatever you call it as AB, is possible. So how do you write order? Generally, we write number of rows into number of columns. Rows P into N means rows into columns. So check here. Number of columns in the first is equal to the number of rows in the second matrix. Then the product is possible. So in the exam, last time in GC also, 1 by 2 and 2 by 3 matrix, and I check this is A, this is B. They asked you to find AB and B if possible. So A, all of them finished because it's right, no? This one too, it's possible. Some of them found out B also. Is BA possible? First write B, then write A. BA possible? Tell me, children.
No, ma'am.
This B, this A. I wanted to find the product of BA. Product AB. Sorry, BA. Is this possible?
No, ma'am.
No, ma'am.
I think not.
No, ma'am.
No, ma'am.
No, not possible. Okay, why are the others quiet? No, it's not possible because this is not the same. Okay, so they might give you some tricky questions, simple questions, but tricky questions like this. Giving you two matrices and asking you to check whether AB is possible, BA is possible. So from the matrix, check if AB is possible and BA is possible based on this rule. Now we'll take a quick example to demonstrate what we have said so far. Maybe I'll take 2, 3, 1, 0, 4, 5. Let this be A, and let me take another one. This is 3, 2. So I would take another one. This is 2, 3. Okay, correct. Now, can I find AB? Can I find BA? That's a question. Let's first start with AB. So if I want to find AB, this is how I find the product. First write whichever matrix is this. So I write A here. Then I write B here. Don't do anything inside. Don't put dot into and all. This is enough. If you write side by side, that itself shows that it's a product. Okay. How do I find the product now? Let's calculate. I hope you know the rule. You'll find out this element with these elements. Okay. Each of them. So I should write 2 into 6, 3 into 4. Understood, children? This into this. Okay. From left hand side downwards. So 2 into 6 plus 3 into 4. That's the first element. Have all of you understood?
Yeah, ma'am.
Yes, ma'am.
Okay. Then the same thing from left, then downwards in the second one. So 2 into 0 plus 3 into 3. Then again the third one, 2 into 1 plus 3 into 7. If you don't follow anything, please tell me, children. And then again left, from left downwards, 1 into 6 plus 0 into 4. Then 1 into 0 plus 0 into 3. 1 into 1 plus 0 into 7. Then finally, from left, 4 into 6 plus 5 into 4. 4 into 0 plus 5 into 3. 4 into 1 plus 5 into 7. Let us simplify this now. So I'll get 12 plus 12, 0 plus 9, 2 plus 21, 6 plus 0, 0 plus 0, 1 plus 0, 24 plus 20, 0 plus 8, 15, and 4 plus 35. I don't know if I've gone wrong anywhere. If I've gone wrong, please let me know. I'll correct it. Then finally, we write 24, 9, 23, 6, 0, 1, 20, 44, 15, and 39. Am I right? So this is the product AB. Now I told you, when I was giving you the example definition, I told you that if you have matrix A with order n by p and matrix B with order p by n, then product is possible because these two are same, and the product will have order as equal to m by n. Did I say that? It will have m by n. This one into this one. Just check here. What is order? 3 by 3. 3 rows, 3 columns. 3 by 3. Correct, children? Have you understood this?
Yes, ma'am.
Okay. I hope all of you know multiplication now. Do you want me to do another problem, or you can try one by yourself? Can you? Yes or no? எல்லாருக்கும் புரிஞ்சுச்சா?
Yes, ma'am. We
Yes,
can try
ma'am.
by
செய்யணுமா?
ourselves.
You'll do it yourselves?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Very good. Okay, you can try this at random. I'll give you another one. You can try this. Oh, I forgot to ask what was that? 2 by 3 and 3 by 3, is it? 3 by 2, huh? What did the
Yeah,
matrix?
ma'am.
What was the matrix that I gave you? 3
2
by 2
into
and
2 by 3, ma'am.
3 by 2 and 2 by 3 kudana.
Yeah, ma'am.
Yes, ma'am.
Okay. So this was possible. A and B was possible. Now is BA possible? BA na
Yes,
first
ma'am.
B எழுதிக்கோங்க.
Password, ma'am.
Then write A. In this case, what happens? BA is also possible, correct?
Yeah, ma'am.
Okay, I forgot to do that. Maybe I don't remember. Has anyone taken down the matrix?
Yeah, ma'am.
சொல்லுப்பா.
A ரோவா காலமா மேம்?
எப்படினாலும் சொல்லு. நீ என்னன்னு சொல்லிட்டு சொல்லிடு. ரோ சொல்றியா?
ரோ மேம். 2 3
சத்தமா சொல்லுப்பா.
2 3
2 3
1 0
1. அப்புறம் இங்க 0.
மேம் இது 3 into 2 மேட்ரிக்ஸ் மேம்.
B மேட்ரிக்ஸ் சொல்றியா?
இது A மேட்ரிக்ஸ் மேம். 3 into 2 மேட்ரிக்ஸ் மேம் இது.
3 into 2. ஓகே சரிப்பா. அப்ப நீ காலம் சொல்லிட்டு இருக்கியா அப்ப?
இல்ல மேம், ரோ தான்
சைடுல எழுதணுமா? ரோ தான் சொன்னா. சொல்லு. 2 3
2 3 1 0
1 0
4 5
4 5. ஓகே, தேங்க் யூ பா.
B
சொல்லுங்க.
601
601
437.
Okay, thank you very much. Okay, so we have these two now. This is 3 by 2 and this is 2 by 3. We found out AB. Let us check if BA is possible. BA na first you write B. Then you write A. And check if it is possible. This is 2 by 3 and this is 3 by 2. Luckily in this particular case, this also matches number of rows and number of columns. So you will get a product and the product will be 2 by 2. All right. What will be the product now? You can try for this matrix. Yeah.
16.
Please do it.
Ma'am, 16.
முடிச்சிட்டீங்களா? Okay.
Yes, ma'am.
16.
23. 35.
23.
47. 47.
Okay. I'll give you 2 minutes time. You can just go through and do it, children.
Okay.
Take your time and do it. See if you have understood the product. Thank you, Ma. Did all of you get this answer? Are you all trying?
மேம்
Yes.
மேம் 35 வராது மேம், அங்கே 39 வரும் இந்த இடத்துல.
35 வரலையா?
ஆமாம் மேம், 39 வரும் மேம். 39 மேம்.
10 வருதா? ஓகே, செக் பண்ணுங்க.
39 மேம். 39 மேம். 10 மேம். 39 மேம். ஆமாம் மேம், 39.
10
இல்லை மேம், 39 மேம். 39.
39 மேம்.
39 சரி, செக் பண்ணிடுவோம். இந்த எலிமெண்ட் இது 4 into 2 plus 3 into 2, 3 into 1 plus 7 into 4. அப்ப 8 plus 3 plus 7 4s are 28.
28 மேம். Plus 39.
30, 31, 39. 39 வருதா? கரெக்டா? கேர்ஃபுல்லா போடுங்க. சரியா? Check if all of you get 39 there. Got it? Any doubts for anybody? You want me to do it or செய்ய தெரியுதா எல்லாருக்கும்? சொல்லுங்க children. Only if you tell me I will know.
Yeah, ma'am.
You have done?
Yeah, ma'am.
You've finished?
Yeah, ma'am.
Okay, so all of you are thorough
Yes,
with okay, fine. All of you are thorough with the product of matrices now. I'll give you tomorrow. Do I have a class with you? Tomorrow,
Yes, ma'am.
do we have a class? Okay, tomorrow also then I'll teach a little bit and then give you some homework for those 4 days holidays. You'll have to work it out and write it in a neat piece of paper, scan it and upload it. I'll send it as assignment. You can finish it off by Sunday night and post it. No problem. Just take time and do it and post it by Sunday. So what I'll do is I'll start considering this as third component. So 10 marks like that, slowly, gradually, when we do things, as and when I teach, it becomes easy. Instead of collecting assignments towards the end and then you also won't study, you will copy from others. That doesn't help at all in any way. Okay. So as and when we study, I'll give you a set of problems. You try to work it out. Then I'll evaluate it and then have a copy of your marks with me. All right, children, you understand? This is the pattern with which I've been working so far. It makes things easier. So I hope you would all cooperate. Yes?
Ma'am.
இந்த பூஜா ஹாலிடேஸ்ல எங்கயா ஊருக்கு போயிட்டு அப்படி இருப்பீங்களா?
மேம்
சொல்லு சூர்யா.
மேம் நான் டீன் கிட்ட வந்து நான் ஆல் அட்மிஷன் கேட்ட கிடைக்குமா மேம்?
கிடைக்கும்னு நினைக்கிறேன்.
along
சரி, கிடைக்கும்னு நினைக்கிறேன். எப்ப வர போற?
ஒரு 16th அங்க இருக்கிற மாதிரி வரலாம் மேம், காலேஜ்ல 16th.
சரி, இங்க வந்தாதான் கேட்க முடியும். எல்லாருமே என்ன ப்ரொசீஜர் பண்ணிருக்காங்கன்னு தெரியல. ஆல்ரெடி அட்மிஷனுக்கு